All right, so we're going to look at transforming our data, and we're going to look at these things called density curves today. So transforming our data will affect the shape, the center, and the spread. And that should make sense, because if we're adding or multiplying our data by some quantity, our measures of center and spread should change. So let's look at how. When we add or subtract a number to all of our data values, we add to our measures of center. The mean, median, the quartiles, the percentiles, they all get bigger by the same amount. But the measure of spreads do not change. The range, the IQR, the standard deviation, they all remain the same. So here's a graphical depiction of this. We have our guess for something in meters and how much we're off from the actual by. So the distribution of our guess is bigger than the distribution of our error, but the shape stays the same. And we can also see that if we run this data, our standard deviation is the same. Our IQR, if we look at Q3 minus Q1, it's the same, 6. The range is the same. But all of our minimum, median, maximum, quartiles, mean, they're all changing by 13, which is how much each data value differs by. When we multiply by a constant, our measures of center all multiply or likewise divide by that number, and our measures of spread get multiplied by the absolute value of that number. But the shape does not change. So here we see the error in feet. Well, meters are bigger, so we're dividing by some number to convert to meters, and now we have the same basic overall shape, but it's just much tighter. Our values got changed, our data values got changed, our measures of spread also got changed, but the spread did not, or the shape did not. And there's the numbers that we're using here. Our density curves, we looked at these in Chapter 1. Look at the data, make a graph, talk about the shape, spread, center, outliers, SOCs, calculate the numerical summary. Now we're going to be looking at data sets that we can put a smooth curve on top of. And our data does such a good job of being regular is the key word, that we're describing it by a smooth curve. And what we're looking at is, if we have something like this, we can approximate all those bars using this curve. And a density curve is always on or above the horizontal axis, and the total area, the total percent underneath it is 100%. The area is 1. So the density curve is describing the overall pattern, not just little patterns, but overall. And when we talk about the height above the y-axis, we're talking about the percent, really, that is represented there, the frequency, the relative frequency. The x-axis would be our score here. So as we move forward through this chapter and into other chapters, we're going to see a lot of density curves. You got to remember that the area underneath it is 1, and it's always on or above the x-axis. Here's a foxtrot comic. A lot of foxtrots are related to math, so take a minute and read it, and you'll see that it's kind of clever. But our measures of spread with density curves, we got to talk about those. We apply those to density curves just like we do to actual sets of data. For the median, it's the part of the density curve where it's split into equal areas. So it's the point that half of the area is to the left of and half of the area is to the right of. And that should make sense. Median is 50th percentile. We just need to figure out where is the area 50% to the left, 50% to the right. The mean is a physical balancing point you can think of. If we were to take that curve and balance it on our fingertip, where would I have to put my fingertip so that it didn't tip off? And the mean and the median for a symmetric curve are identical. They're the same. They both are in the middle, the highest point of that curve. The mean of a skewed curve is pulled away from the median in the direction that it is skewed. And we should remember that from our investigations with what measures of center are influenced by outliers and skewness. So here's a picture of that. Mean and median are the same right here. As soon as we skew it to the right, the mean gets pulled off of the median and bumped to the right along with that skewness. So here's what we looked at this section. A lot of conceptual understanding, not so much calculations yet, but we'll get there, guys. Don't worry.